Hey mathematicians, here are your notes for 3.4, talking about solving two-step equations. So today's bell work is just a quick review of yesterday's lesson. If 6m is equal to 12, what is the value of 10m? And then I want you to show all your relevant steps to prove it. So go ahead and pause the video right away here, try this on your own, and then come back and we'll work through it. Alright, plenty of time to work on that bell work, so let's get to it. Remember yesterday, we cannot solve for the value of 10m if we don't know what the value of m is. Because in order to be able to solve this, we need to be able to plug a number in for m. So let's jump over here. In order to solve for m, remember it's being multiplied by 6. In order to undo multiplication, we divide. That then gives us a 1 in front of m. 6 divided by 6 is 1, so we isolate it. And whatever we do to one side, we must do to the other. 12 divided by 6 is 2. This is our answer for m, but it didn't answer the original problem, which is what is the value of 10n. Now that we know that m is 2, we can get rid of m, plug in the number that we have, and solve to find that our answer for the value of 10m is 20. Now that was just a one-step equation, so today's goal is to be able to solve a two-step equation. And notice I didn't say with addition, subtraction, anything like that, because with two-step equations, we're actually going to be combining everything that we've learned in the last two lessons together. Before we start though, a quick lesson in working backwards. A bacteria culture doubles each half hour. After 3 hours, there are 6,400 bacteria. How many bacteria were there to begin with? Well, let's look at this one. And I'm going to make a table just to make it a little bit easier on myself. I'm going to put time on top, and I'm going to put number of bacteria on the bottom. I know at 3 hours, there were 6,400 bacteria. And it says that it doubles each half hour. So a half hour prior, at 2.5 hours, there was half the amount of bacteria, meaning there was 3,200. If I go back another half hour to 2 hours, there was half that many, meaning there was 1,600 bacteria. If we keep going with this to 1.5, 1, 1/2, 0, we can get all the way back to how many bacteria there were at the beginning. Half of 1,600 is 800, half of 800 is 400, 200, 100. So at time 0, at the very beginning, there was 100 bacteria present. Now, why did I show you that we're working backwards? Well, let's jump into the two important things to remember. We always want to undo our operations to solve. Undo operations to solve. Meaning when there was addition, we used subtraction to solve. When there was multiplication, we divided to solve. And the thing that I want you to remember is if you show your work, not only will it help you remember what steps you took and in what order you took them in, but it will also help me help you if there's any issues that come up. Remember that our goal from yesterday was to get the variable alone, and that is going to stay our goal in our two-step equations. Get the variable alone, and of course, check/circle your answer. Now, why am I saying all this? Why am I talking about working backwards? Well, usually when we work with order of operations and PEMDAS, if some of you remember calling it that, we always want to do multiplication division first. However, when we're working backwards, we want to work from as far away from the variable to closer to the variable. So in this case, instead of getting rid of this division first, I'm actually going to use addition and subtraction first. So, in this case, to solve for 3x, I need to get this positive 2 away. It is farther away from the variable than this 3 is, which is really up close and tight using multiplication. So, To solve, I'm going to start by subtracting 2. I'm going to put a bar there. This is me showing my steps. That cancels on the left side, and I'm left with 3x equal to 15. Notice, I'm not done yet. I do not have the variable alone. So I have to keep going. Now the closest number to this would be 3. How do I undo multiplication by 3? I divide. Again, put my line to remind myself that's where another step started. 3 divided by 3 is 1. 15 divided by 3 is 5. Now that I have my variable isolated, I can box it. Let's see this one again. Notice my negative 13 or my minus 13 is farther away than my 5, so I'm going to deal with that first, working backwards against PEMDAS. We always want to take care of subtraction and addition first. We're left with 5z on the left. We're left with 35 on the right. We're not isolated yet, so let's get rid of that multiplication by 5. Line. Z equals 7. I now am isolated. There's nothing else going on, so I box it. And then, of course, check your answer. All right. I'm going to give you just a minute to go ahead and try those 4. If you want, you can even try the challenge on the back. All right. I left you on a hard one, and I'm okay with that. I hope it challenged you a little bit. Because, remember how I said we're working against PEMDAS, so we always want to deal with addition and subtraction first. Here's the issue with this one. When I rewrite this so that it's not, so that it is not a division like this, but a division like this, you'll notice that the number farthest away is actually not the plus 6, it's the negative 3. And in order to do this one properly, I need to actually work with that negative 3 first. It's the number farthest away. So, instead of minusing 6, and then having to deal with that negative 3, I'm going to right off the bat multiply this entire side by negative 3. If I do the same thing to the right, I'm then left with m plus 6 equals negative 12. Notice, in doing that, in multiplying by negative 3 right away, it got rid of the fraction, so I didn't have to deal with it at all. We like that. We don't want to have to work with fractions any more than we have to. Let's keep going then. Now that I've gotten rid of that negative 3, the next closest number is that positive 6. I'm going to subtract over. I isolated my m, and I get negative 18. I want to reinforce that I may have said something incorrectly over here in the video. When I say that we're working with addition and subtraction first, what I'm meaning is that we're always working with the number that's farthest away. In these first two problems, that number was an addition or subtraction step. It wasn't necessarily the multiplication going on. So, maybe if you want to put a third little note up here, work with number farthest from variable first. And that will ensure that you always do the correct steps in order. So in this case, we have 15 minus 3x equals negative 6. Remember, if we're trying to move things away from the variable, we need to decide if we're going to move that 15 first or that negative 3. In this case, the 15 is the farthest away, so that's the one that I'm going to move first. So this 15, I'm going to subtract it over to the other side. That cancels on the left, so I'm left with negative 3x. Notice the negative, didn't go anywhere. It's attached to the 3. It's not attached to the 15. Equals negative 21. Now that I have that addition subtraction taken care of, I'm going to use my division. Another step here. Negative 21 divided by negative 3 is positive 7. I'm isolated, so I box it. Here's another one. This one's tricky. What number is farther away, the addition of the 6 or the division of the 2? In this case, it's the 6, so let's move that away. 2 equals p divided by 2. How do we undo division by 2? We multiply both sides by 2. That cancels the numerator there, denominator. So we're left with 4 equals p. This is a perfectly okay answer, but as I said in my last video, I prefer, it is technically better looking to have the variable on the left. So that's my answer. And this last one, it's tricky. There's a lot going on here, but just follow those steps. Remember, farthest away. In this case, that's the 3/8. So we're going to subtract it, undo addition with subtraction. I'm left with negative 1 3/8. Though I don't really like that, I'm actually going to change that to be an improper fraction, which will be negative 11/8 equal to 5/8 b. This is being multiplied by a fraction, so in order to undo it, we multiply by the reciprocal. Do that on both sides, multiply by 8/5. New step. That cancels. 5 divided by 5 is 1. 8 divided by 8 is 1, so we're left with b on the right side. Negative 11/8 times 8/5 is going to be negative 11/5. Make it look pretty by switching your variable to the left side and box it. Circle it, box it, whatever you like. And last but not least, let's check out that challenge on the back. Translate the following into an equation and then show all steps to prove it. Problem, the sum of x and 4 is divided by 10, and then 22 is subtracted. The result is negative 20. I think the hardest part of this challenge is actually the translation of it. There's a lot going on in the second half of this sentence, and we don't want to mess it up. If we do, we obviously won't get the right solution because we didn't set the original problem up correctly. So let's jump in. The sum of, remember that is a key indicator for parentheses. X and 4, sum, x and 4. The sum, that whole thing, is divided by 10. So I'm going to divide it by 10 this way. You could also put division behind it, but I think it looks nice. It says, and then, so after we've done all this, 22 is subtracted. The result is negative 20. Well, the result would be the solution, meaning this would be equal to negative 20. Now that we have it set up, it's the simple solution that we were looking for before. The number currently farthest away from my x would be this 22. It's not even in this little stack going on. It's over here by itself. So I'm going to add that right away. Plus 22. Draw my line to indicate a new step. X plus 4 divided by 10. I'm going to lose the parentheses here because there's no multiplication going on outside. There's just that divided by 10, which I know. It equals positive 2. The next number farthest away is kind of hard to see, but if you remember that this left side could be rewritten as x plus 4 divided by 10, the number farthest away from the x is that 10, which means that's the one we're going to deal with next. It's currently being divided by 10, so we're going to multiply by 10. Whatever you do to one side, you're going to do to the other. So we're left with x plus 4 equals 20, and then finish it up by subtracting 4 from both sides so that you're left with x equals 16. And then, of course, as always, box your answer and I encourage you to go back and double check by plugging it into your original problem to make sure that it works. Go ahead and go do your practice. Let me know if you have any questions.